represented a portion of Russian. Well, now during the presentation, the models observe the phenomenon and make an explanation based on diffraction. She separated two main cases of small drops and big drops. Yes. After it, he gets the photo of water vapor on the slide and say that the distribution is random. And after it, make some calculations using some formulas, but don't say some references where she get it. Also, I want to point some strengths. It was a lot of photos of experiments. She used some different drop size and studied it to and find the inverse color on the pictures. In the theory, there is a diffraction explanation and consider small and big droplets model. Also, there are weaknesses in experiment. It is about it's not clear comparison with between the theory and experiment. And she breathed on the glass. It was very not mechanical, and from one experiment to another it can be different. Also in theory there are a lot of some formulas were not unclear, and she rushed the presentation and it was hard to understand. No, and the theory experiment, as again, there was no comparison. Next, please. Oh, now we would like to discuss the next points. Could we suppose that the distribution of droplets in the fog and the one on the Misty glass is completely random? And you want to...
So they start the clock is okay.
Yeah. About random distribution. I'd like to... Could you open the slide with drops in glass?
That the distribution of our drop on the glass are really random. And about
one thing. Could they overlap drops?
What do you mean?
This drop and this drop, they are overlap. Could they overlap here?
If at this moment we can observe this but and when they overlap, they put on each other and they can see the biggest drop. And of course, because of this, we have a random shape in some cases.
No. All in all, they can't overlap, and it means that there is some order between them. And another one thing, what is the distance between two droplets, the average distance?
It's randomly too, as you can observe.
But you can see that there are some average between such.
Okay, we have some distribution of this distance, and of course, for example, when we have a small drop, we have one distance. When our drop increase, and as you can see in the video, they are not stationary.
I see, but am I right that the distance between the droplets is comparable with their size, for example? Between the neighbors,
between the drops are smaller than parameters of drops.
they're comparable, yes? It means that there is some short-range order there, yes? Some order in the distribution. And the distribution is not really
what do you mean that distribution is not really random? Distribution of drops on the glass, it's not symmetrical. We can observe some systems. That's why we can say that they are random and they can change it.
No, the scheme is not necessary, but the order can be without system. But, oh no, and you say about open disks too.
I said that we can approximate small drops like this.
Right.
Because the difference of phase inside the small drops are really small. We built a mathematical model for this case, and not only in qualitative explanation. In our mathematical model, we can observe that yes, we have some small difference, but it's really small. That's why we can say that phase difference are quite small.
What is the main difference between drops and black disk?
Between drops and black disk? Because when we have a black disk, we have a diffraction only at the border of our drop. And when we have a drop, we have some different paths inside the drop. That's why we can see that.
But when, am I right that when rays go to the water, it goes refraction?
In this case, we observe the wave optics. That's why we can say that it's not clear to say about geometrical optics in this case. And you can see when we have a small drop, of course we have some different features, but when drops are small, this distance similar.
Does the drop refract the rays? Refract the light? This is one question. Does the drop, small drop, as in your question, in your case, refract the light?
You can observe that in this case we have a plane waveform, and it's plane too. And in this case we have a diffraction. It's not clear to say about refraction in case when we discuss about diffraction. Because this point secondary wave generation, and it's not clear to say about rate, to say about rate.
What are the characteristic types of drops?
Characteristic size, what do you mean? The radius of the drop?
Yes, yes.
As I said, it can be like 10 micrometers to 20 and
And what are the wavelengths about?
Wavelengths are about, for example, for green color, it's like 500.
And you really think that they are comparable? The two sides that you said before are comparable? That you consider the diffraction?
Okay, you mean that we have a geometrical optics effect in our...
No. I say that you say diffraction. It is diffraction on all the drops. And but there is some difference because could you write the distance size of the drop?
Our drops are and our wavelengths, for example, and our wavelengths are, for example, we can say that it's not so big difference, so we can talk about difference.
It is that 100 times bigger. They are not comparable. Right?
Okay, and if they are not comparable, it's not diffraction. And you said that it's geometrical optics. It's the refraction and diffraction.
No, I say only about your model. And find that there is some wrong thing.
I mean that the diffraction model is correct for.
And what are the main things that you catch from the experiment?
What do you mean?
That you obtain from experiments?
Our thing for experiment. It's the difference between light.
No, your results. What you obtain as the all in all from experiment?
What we intake in our we have our image. We have a distribution of intensity for different wavelengths in our experiment.
And from theory?
From theory, we build distribution of intensity for different wavelengths too.
And where could you compare them? Could you show both of these slides with results? And from experiment, you can. It's your final results from theory. This one.
Yes, it's for big drops.
For what?
For big drops.
Drops. And how do they relate with? How is? Could you compare it with experiment results?
We haven't plot on which we have experimented as theoretical but we can test that the graphs was built in a similar scale, and they are really similar.
And another one question. In your theory, you use some distribution, some size of drops, yes? Radius is. So, what's the radius you?
For small drops, it was like a mechanism. For big.
It is constant. It was constant.
In theory, it is the constant.
And distance between the drops.
Distance between the drops, we have big way to experiment distance. We calculate the average between them and put this average in the...
Again, constant, yes? It means that you have several arrays for diffraction.
Okay, but in the theory, we of course tend to do some random distribution, and we can put this parameter randomly of our theory.
Thank you.
Okay, we have 1 minute now for the opponent to summarise, please. The time has started, you have 1 minute.
We discussed the explanation of phenomenon. It was diffraction, and there are some wrong things because of distances between the drops, and we find out that there is some order between droplets, and there is it is not completely random distribution. Also, I try to understand the theory and its basis, and we try to to compare it.
Thank you. Okay. If you could both remain there, please, now for questions from the reviewer.
Okay. I have several questions for you. For both reporter and opponent, what effect can water drops make to the light rays going through the Misty glass? What effect can be occurred?
The most important pressure and dispersion have a big difference in case it's
Okay, only two. The refraction, dispersion due to the refraction,
yes.
and the difference. Okay, what about you?
I say that it is refraction on the water droplet, and every drop refracts the light, and in fact, there will be the effect.
Next question to the reporter. So you mentioned that diffraction is important for that phenomenon. Then can you explain the condition for the light ray diffracted to make the pattern, the distinct pattern? Can you explain the situation when it makes the pattern?
Okay. The condition when our light source you can see that this part is the second wave generation, and we said that it's put waveform in every case. That's why we can say that it's in every case. That's why I said that it's not correct to say about the refraction. But refraction
okay, so I also asked, you used the mathematical model. So for that equation, what is the basic assumption of the light source? What is the basic assumption? The situation. So light has to be somewhat related to coherence or
we
not?
have plain waveforms in our theoretical model.
Okay. Next, so you divided into big drop and small drop. What is the criterion to define big drop and small drop?
This is
Okay. So that's in the code. So what is the physical meaning of that?
The physical meaning that in a case with small drop, the difference between this distance and this distance are quite small, and we can see that the difference in phase are quite small. And when we have a big drop, the difference between this and this side are really big. That's why we can compare.
Thank you very much. And for the opponent, you mentioned that the random distribution is not complete. So what do you think the effect of random distribution, the distribution of the water drop?
5 seconds to answer this.
If the distribution is random, then the result on the screen will consider with diffraction on one of a piece.
You can consider as one over.
That's answered this
Thank you very much.
Good preparation.